Example. So let's do the same basic situation again. Before we said we're looking at a drug, and when we're looking at a drug, look at this example number 2.
We have more than one level.
We have more than 2 levels. We have a total of how many levels here?
4.
We have 4 levels, so we have 1 independent variable, but now we have 4 levels. What about dV? How many dVs do we have? By the way, that's a trick question. It's still 1. Everything we cover will just be 1 dependent variable. That's a graduate level class if it isn't. So we have 1 dependent variable. So could you do t-tests on this?
No.
Well, if you wanted to, you couldn't look at all 4 at once, could you? You could actually do t-tests if you just compare like the no drug to the low to the high, the middle to the high. You could do a bunch of t-tests. So technically, is this making sense or no?
My head hurts.
Your head hurts. It's going to get a little worse, sorry.
It's okay.
You could, well, that's why we record as well. You could do like a bunch of t-tests on this, but statisticians would never do that. Because if you do a bunch of t-tests, you run the risk of actually having that type 1 error, that having something significant from just running too many tests. So you could run a bunch of t-tests on this, but that wouldn't be appropriate. You don't want to run a bunch of t-tests. What we do for this is we can still do, guess what? An ANOVA. So if you have more than 2 levels, it's best to do an ANOVA. And what I'd like to show you how we're going to do is I'd like to show you how we do an ANOVA on this. Let's see if I made my little cheat sheet notes. Oh good, I did. I did this last night. So, let's take a look at this. So I got an SPSS printout, but notice I'm missing a few things here. So what am I missing in this first table? The means. So let me hit the pause. All right, how are we doing? Got a few means? See if we can fill this in. Well, actually, I don't need to fill it in. What'd you get for the first group? For the no drug group? It's pretty easy at a 5. How about the low drug group? 4. How about for the moderate dose? 2. And for the high dose? 1. Actually, we need to change the example just a little bit, because remember what the example was from before? It was a drug affecting memory. So let's change this one. Let's change the dependent variable, not to memory, but another favorite thing to measure, pain. Most things have been memory or pain, right, this semester? 2 states that people are very knowledgeable on. So the hypothesis, of course, at the highest dose, pain would be what? The lowest, yeah, least here. What is the, did you figure out the grand mean here? 5 plus 4 plus 2 plus 1 is what? 9, 10, 11, 12 divided by 4. So the grand mean is 3. So how do things look here? Is this good news? Is this bad news? Does it look like the drug is working? Does it look like it isn't?
It does not look like it's working.
You can't really tell. You got a lot of different things. If you compare no drug to the high dose, does it look like it's working? Yeah, the 5 to 1 kind of looks like it, but that's what we'll evaluate now. So now what we have to do is we have to get to the next part of the table and actually do the ANOVA. So we need to compute here the sums of squares between groups. This might be, let's see. Ashton, I'm going to turn off the board right now.
Alright.
It does an AV mute. So let me do that, and I'm not sure if you'll be able to hear me or not. I know I can't hear you. That is, oh, that's right, because it's coming out of there, isn't it, for her?
She can hear you, but you can't hear her.
Okay, so I won't be able to hear you, but don't worry, we'll put you back on in a few minutes.
Alright.
Don't take it personally. Okay, so how are we going to do this? How are we going to get this particular product? How do we get the sums of squares between groups? Actually, let me keep it on for a minute. We'll talk about it first, and then we'll do it. Ashton, I decided we should talk about it first and then figure it out. How are you going to compute the, you need to get the sums of squares between groups. So what would we use here? What do you need to compute the sums of squares between groups?
Well, you got your mean, you got your mean.
Say again, Christy?
X bar minus X bar.
So you need the cell means. So what numbers are those? The things we just got, right? 5, 4, 2, 1, 1. And you need the grand mean, which is what? 3. And you need to use the formula n times the quantity, what? N times the quantity x bar minus x bar bar squared. So you'll need to use the formula n times the quantity x bar minus x bar bar. Your book says g for the grand mean squared. What is n? Is it 3 here?
No, 5. No, it's not.
It's 5. You got 5 here, so see if you can do the math. It shouldn't be too complicated. And see if you can get the right result here. Let's give it a shot here. So what did you guys get for your sums of squares between group? Everybody get 50? Did you get 50?
I'm really happy to say I got 50.
You got that smile on your face. Ashton, did you get 50?
Yes.
Very good. So once again, do we want that number to be high or low?
We want it to be high.
You want that number to be high. You want that number to reflect the treatment. So you're hoping that number is high. It's hard to tell if that's really high or not. Let's go with the rest of this table. Or should I let you? You know what? It'd be better if I paused again. See if you can fill out the rest of the table and get the F score. Okay, let's give it a shot. Between groups, degrees of freedom. How many degrees of freedom do we have between groups here?
That's great.
So Ashton said 3. You're going to have to get over your shyness problem there, Ashton. Is she right?
Yes.
Yep. How come it's 3?
Because you did the number of groups that is 1.
There you go. So you can always even go backwards. So it's 3 there. How about degrees of freedom within groups?
You got 16.
What do you guys think? Is 16 right or is it wrong? 16 is correct. How did you get 16, Ashton?
You did the number of samples in a group minus 1. So you did it for each group. So you have 5 minus 1 plus 5 minus 1, so that's
Yep. 16 is correct. Did the rest of you get 16 or can you see 16 now? Okay.
Say what she just said again?
So to get the 16, you have to look, for example, in the group that got no drug. How many were in there? 5. Take any group, take 1 away. There's 4. Second group, there are 5 in there. 4 again. So you just do n minus 1 within each group and then you add them all up.
Do you have that one formula, the k times n minus 1?
It could, yeah. So the formula might be useful. It does the same thing. K is the number of groups. And then n minus 1, how many in a group minus 1. Yeah, it does the same. Some people prefer that. Some people just kind of like seeing it and just, oh wait, I get it. Because it's within group. So how many do you have in a group? Take 1 away and do that for each group. But yeah, same thing. So we got 16 there. What is the value for the variance within, between group then? What is the variance between group? 50 over 3 is, sorry about that unevenish number, 16.67 or so. Is that working? How about the variance within group? What is the variance within group?
It's 2, isn't it?
Say again?
Is it 2?
It is
Because
2.
if you did 32 divided by 16, you get 2.
There you go. So, yeah, is this good news, the fact that the mean squared between groups is 16 and within groups it's 2?
Yes.
Yeah, it is good news. You get an F score of 8 and some change, but I think it's what, 8.034 about? That sound right? And actually, you didn't even have to do any of the computations because what did the final column already tell you?
The standard deviation.
No, not quite. The final column.
6 is 0.001.
So this tells you that this result is
Significant.
statistically significant. So we have a significant result. How would we write out the F statement here? A little more challenging. F of what?
F, 3.
There you go. F of 3 comma 16. Use the degrees of freedom for between groups, comma within groups. F parentheses 3 comma 16 equals what? 8.34 comma P.
P is less. P
It's a-
equals 0.001.
P equals, correct. P equals 0.001. It's kind of nice the way the acoustics are, Ashton. You're kind of coming through as a godlike figure above the class. Which is better than Bane in Dark Knight Rising. And now we're going to kill all of you. Wow. Anybody see that one?
Yeah.
Did you like it or
Yeah.
no? I really enjoyed it. Family's like, get the hell off the TV.
I must put up my opinion though. The original Batman's are better.
Okay, well, you're entitled to your opinion, even if it's wrong. Just kidding. Oh,
Back up for a second.
sure.
I got lost because I write really slow. With the
Really, really neat.
I tried. I have to read it later and
Yeah.
Go ahead.
variance between groups and then everything.
So the variance between groups, how did we get the 16.67?
Right.
50 divided by 3. So it's the sums of squares between groups over the degrees of freedom between groups.
And then for the variance
Within,
within, yeah.
sums of squares within group, 32 over degrees of freedom within group, 16. So you get a variance within a 2, and then you divide them. So you'll probably get something like this. For your competency, where you'll have to do some partial work here and figure it out. So, yeah, that's kind of how the game works. But we're not actually quite done here, because now we need our real-world conclusion. Actually, I'm going to stop